In this problem, ABC is an equilateral triangle and M is a point inside it, wherever. And H1, H2, H3 are the projections from M onto AB, BC, and AC. And the question is to prove that the sum of MH1, the distance, plus MH2 plus MH3 is a constant, and to calculate it. So how do we proceed? First of all, we draw the three triangles like this: MEB, MEC, and MBC. And we calculate their areas. The area S1 of the triangle MEB is equal to the altitude MH1 times the base AB divided by 2, which is of course MH1 times E divided by 2. The area of the second triangle MEC, S2, is equal to MH3 times the base AC divided by 2, which is equal to MH3 times A over 2. And the last triangle MBC, the area of MBC S3 is equal to the altitude MH2 times the base BC divided by 2, which is MH2 times E over 2. Here AB equals AC equals BC equals E because it's an equilateral triangle. Now the area of the triangle ABC S is of course S1 plus S2 plus S3, which is equal to, we replace S1, MH1 times E over 2 plus MH2 times E over 2 plus MH3 times E over 2, which is of course equal to, the common factor is E over 2 times MH1 plus MH2 plus MH3. Now we have our sum and we have S in the other side. We have here S. So by dividing S by A over 2, we will get our sum MH1 plus MH2 plus MH3 is equal to S over A over 2, which is equal to 2 times S over A. Now let's calculate the area of the triangle ABC. S of the triangle ABC, AB times AC times sine the angle E divided by 2. This is the formula of the area of a triangle, even if it's not equilateral. In our case, S equal A times E, AB is E, AC is E, times sine pi over 3 Since it's an equilateral triangle, we know that angles of an equilateral triangles are all equal to pi over 3. And we know that sine pi over 3 is square root 3 by 2. So our surface S is equal to E square root 3 by 2 by 2, which is equal to E square root 3 by 4. Now we replace in our other formula and we will finally have mh1 plus mh2 plus mh3 equals 2 times s, which is E squared square root 3 by 4 by A. Here we have A, which will cancel, and 2 will cancel with 4, so there remain and 1, 2 here. So we will have A square root 3 by 2. So we have proved that wherever the point M is inside the equilateral triangle ABC, the sum mh1 plus mh2 plus mh3 is equal to the constant A square root 3 over 2.